Today's topic is going to be primarily about working with Fusion 360 electronics on the schematic editor. In earlier webinars, I had been presenting how to create connections through your components, but there's a lot more involved than, yes, running a net from one pin to another pin. So there's types of way that you could do pin breakouts. You could define the transfer of component connections between sheets. And Jorge today is going to do a demonstration in which he's going to show you the different techniques that there are available and how to create the symbols. That way your frame keeps up to date the connectivity between your sheets or even on the same sheet as well. Well, we're 4 minutes in and the room is pretty packed. So I'm going to go ahead and mute my microphone. I'll be manning the chat as much as possible, and I'll mute myself and let Jorge go ahead and take over. Thank you very much, Jorge. And I appreciate it. I know we're all from home, but I think everything's going to go well this time.
Yeah, thanks everyone for joining us today. I'm going to go ahead and just show you a couple of techniques for connecting things in your schematic, and there's going to be also a few good rules of thumb and principles to understand when working with Fusion Electronics and defining your connections in the schematic. So to start, first thing we need to do is be able to put in a couple of parts to connect. And again, the example is going to be simple, to a certain extent trivial, because the idea is just to show the feature itself. Once you guys know how the features work and what they contain, then you can see how to apply them in your own designs. So I'm going to just bring in this component. I'm going to bring in 2 of them. Okay, we're going to play with a couple of things here. Okay, I'll put this here. Put its power pins there. Okay, that's good enough. So now let's go ahead and just zoom in a little bit. Okay, you can all see these 2 parts. Now, the first thing, or the most obvious way to connect anything in the schematic, is just using the net command and going from point A to point B. Okay, this is the most common. It's also the simplest. Now, it has the disadvantage that if you have a very dense schematic and you have a lot of nets overlapping each other, it becomes difficult to read and to follow the flow of the design. So in that situation, you're going to run into the second most commonly used thing. It's not a requirement in Fusion Electronics to explicitly connect point A to point B. The connection is actually defined by the net name. So for example, let me go ahead and delete this segment. Okay, just going to move this one back a little bit. Move this one back. Okay. Now we have these 2 little net stubs. They're not directly connected. We can agree on that. However, we can make them connect by giving both stubs the same name. And we can do that using the name command. So I'll click on this stub and I'll call it test, let's say. Now you'll notice that the name command allows you to immediately place a label if you wish. I'm not going to do it in this case, and I'll tell you why in a second. So this is test. We go over here. Again, I'll take that off. Test. Okay. It's going to ask you to connect into and test. You'll say yes. Now these 2 are connected. Now, typically, you don't want to just leave it at that, because on a printed sheet of paper, it's going to be hard to really even determine that these 2 are connected, because if we have a whole bunch of stubs on these, then there's no way to map them. And that's where the label command comes in. So you can use label. You can click on the stub and you'll see it'll pop out right there. And we can put that right there. And now we've indicated that they are connected. As long as both stubs have the same name, they're connected. Doesn't matter where they are. So for example, I can make a new sheet and I can just draw a net here. Okay. And if I name it test like I did in the other ones, say okay, I put the label there. This is connected to the other 2 on the first sheet. So that's principle number 1 and the most important one when working with Fusion Electronics and wiring up your schematics. Net name is what defines connectivity. So as long as you have nets that have the same name, they are connected. Doesn't matter where they are in the schematic. Okay. There's one small exception to that, but we won't be getting into that in this webinar, and that's hierarchy. In hierarchy, things behave a little bit differently. But 90% of the time, when you're not using hierarchy, this rule applies. Net name defines connectivity. So this is kind of the two key points about the net command. You can, like standard, just draw a point-to-point connection, draw the net, or you can do net stubs. Now, one thing with these labels that's interesting to note is right now this is a normal label, but we can change it. So if I select it and go to the inspector, you're going to see that it has a property called xref. Okay, and xref stands for external reference. And what this does is it'll change the text and it'll give it a flag. Okay, and the information after the slash is basically the nearest instance of that net relative to the current sheet.
Hey, George, if you don't mind, can you tell us a little bit about the inspector and why did you use it?
So the inspector is a good way to see the attributes of any item you select or a group of items. If you pick a group of items, then what will happen is it'll show you the common attributes between them. Okay? So it's just an easy way to look at the properties of an object. Normally I would have it open, but as you can see on this monitor, it takes up a lot of screen real estate. So I have to hide it, but I can pop it out whenever I need it. So that's something that if we recommend, if possible, to just always leave open if you have enough screen real estate to do that. If not, you can just use a little arrow mechanism here and hide it. Okay?
Thank you, Jorge. I appreciate that, man.
So you're going to notice here on the label, you have the name of the net, you have a slash, and then you have some information afterwards. The first number by default here is the nearest sheet that also contains this net. So as we can see, sheet 2. Now it has question marks because on sheet 2 I don't have any frame. I haven't put any frame here. So if I add one in, which I can do using the frames library from Eagle. Now keep in mind all the libraries from Eagle are available. So if you need more than what's just included with Fusion right now, you can get it by just going to the Library Manager, the Available tab. You'll see all of the Eagle libraries as well as libraries that have been contributed by different manufacturers and things like that. So it's a good resource. It's good to inspect available. Also, your managed libraries that you haven't downloaded will show up here as well. So it's a good thing to be aware of. So I'll go ahead and just go to frames now and just bring one in here. Okay, there we are. And embedded in this frame, in this outline, it's not visible, but embedded in it is actually a grid system with letters on the vertical axes and numbers on the horizontal. So now when we return to sheet 2, you'll see that it tells you exactly where the net is located. So it's a good way to cross-reference, hence the name xref. Some people like to use it just because it gives you a little flag outline. You can use it that way, but this is really its intended purpose. Depending on how you orient the flag, it can actually change what the nearest instance is. For example, here we just have on sheet 2 the nearest reference, so that's what it's going to show. But if we had a 3-sheet schematic and this were in the middle, this current sheet, if we point to the left or up, it'll point to the nearest reference in a previous sheet. If we point to the right or down, then it'll point to the nearest reference in a subsequent sheet. So it's kind of an interesting feature that the xref has. So right now we've covered in depth the entirety of the net command. This is basically all there is to do with the net command. However, there's another command which is extremely powerful, and that involves breakout. Okay, so if you right click on a component, you'll see that you have this option breakout pins. Now you can select specific pins to break out. You can select all pins, And when you select all pins, you'll notice that you have some options for the breakout. Okay, you can basically in one go extract stubs for the components. So let me show you what that is. So breakout pins, all pins, and we're going to say pin names. Okay, you give it a second, and it's pulled out stubs and it's given them names. Now, if I do that over here and I do the exact same thing, you're going to notice that now it's going to want to connect because now we have same names. We'll create duplicate names. This with same names will automatically be connected. Continue. Yep. Okay. Now in this case, like I said, this is a trivial case. There are occasions where you will want this behavior, and that's why it's available. If you don't want it, what you can do is you can go ahead and use one of the other options, which is unique. So if you go breakout pins, all pins, make them unique, now you know they're going to stand on their own. And it makes them unique by basically identifying it by reference designator, gate, and then the pin name. Okay, and that guarantees that these nets will be unique. So this is a really good way to wire up large components because it's clear, everything is labeled, and it can make it easier to track the design flow. So definitely something to keep in mind. Now, the breakout pins feature has other functionality that we're going to explore a little bit after we show you buses. Okay. So I'll go ahead and delete these for now. First, what is a bus? So a bus is basically a container of nets. In its most simplest form, it's just a container of nets. Now, with the implementation of electronics, it's actually able to do much more than that. But for the initial introduction, you can think of it as just a container of nets. So I'm going to go ahead and just draw it. Let's put it, I'm going to put it over here. Okay. Now, if I just left click it, I can keep adding vertices to the bus. If I double click it, I'm going to be brought to the bus dialog. Okay. This is the bus dialog. Now, how does this work? If you notice, there's predefined buses that we can use, and they can have an alias. So for example, an I2C bus is going to have an SCL and an SDA net. Okay, so if I pick that one, you'll see that it has that alias and it's going to contain those two nets. If I click OK, that's what this bus is going to contain. It's going to connect those two nets. Okay, and you can obviously create your own. You don't have to just use these. Now, before we go exploring that a little bit more, I'm going to show you an interesting trick related to the breakout pins here. So right now, this bus is empty. This bus contains nothing. If I select it and I go to the inspector, you're going to see it's basically an empty bus. There's nothing in it right now. Okay, and I widened it because in the inspector I was hovering over the width. I think it's 0.8, I'm pretty sure. Nope. It's acting up right now. Just go ahead and just redraw it. Whoops. Bus. Okay. So now, a couple of interesting features here. Let's go ahead and let me see what's, okay, I know what I want to show you. So one thing you can do is if you use a name command, and this is the most old school way, okay, but it's good to show, it's good to be aware of it. You can change the name of the bus to define what nets are in it. So for example, I can put in commas, A, B, C, and then I can put Y, square bracket 0, period, period, 7, close square bracket, and say OK. All right, and that's what the bus now contains. So if I select the net command and now click on the somewhere on the bus, you're going to see that I get the list, and I can choose which nets I want to break out. So now I've selected that one, and I've broken out Y0. So when I click on it, place it, I can use the inspector. We can see that this net is in fact Y0. Okay, so it can be a useful tool for connecting these types of groups of signals that make sense when grouped together. So as you saw in the predefined buses, those were SPI squared C. Those communication protocols, it makes sense to treat them almost like a unit and only break them out when necessary. You'll be able to see that using a bus really simplifies the drawing of the schematic. So it has lots of advantages. Now there are a couple of really interesting things that you can do with that though. For example, if I make a selection that includes a bus and a component, and I right click on that component, you're going to see connect pins to bus. And if I do that, you're going to see that they were automatically connected. Now it looks like it probably wasn't able to get this one because there wasn't enough room. Okay, but that can save you a lot of time, and it's a very useful function. So those are things that aren't immediately obvious. They're not part of any of the menus up here, but you'll see the option if you right click on a component. So very powerful, can save you a lot of time. Now, I showed you kind of the old school way to define a bus. So let me show you the new way. So I'll go ahead and delete this one, and I'll delete the bus itself. Okay. I'm going to delete these little bits over here. There's a reason why I'm leaving the nets. So I'm going to go ahead and break out Y0 because I do want to do something with it. Y0. Let's just make it pin name. Okay, so as you can see, you can do it on an individual pin by pin basis. Yes, let it out. That's okay. Awesome. Now, here's a cool thing. If we go ahead and group this and we right click, it's probably because it contains the labels. So let me change the selection filter so it doesn't get the labels. You hold control and then you can just disable label. And you see that there's an option called make bus. So if I say okay, and I click on that and I just draw it out, I say from here, you'll see that now this bus that I've created already contains those signals. Okay, so there's a lot of power here. It makes it really easy to interconnect large groups of digital logic, memory buses, things like that. Now, one thing here that's interesting is I mentioned that to a first order, you can kind of treat this as just a container of nets, but it's actually more powerful than that. So I'm going to give this alias, I'm going to call this group just a Y bus. Okay. So there we are, Y bus. Okay, we're all clear there. I'm going to go ahead and delete this little guy right here. Now to Y bus, I can do the same thing I had done before. I can select this one, and I can say connect pins to bus, and it does the magic. Okay, it ends up placing these a little close, but it does it. Now, one thing that pops up, and this is something to keep in mind for whenever you're going to use a bus across sheets. This definition now, this Y bus definition, has been set in stone. Okay? Let's say that on sheet 2, you want to use Y bus. That's really easy. We use bus command, take it over, draw it however it needs to be, double click at the end, and we say from the ones in design, Y bus. That's what we want this one to be. Okay, it says you're introducing a new instance which already exists in the current scope and the current design. Any changes you make to this bus will affect all existing buses of the same alias. Continue, yes. Okay, so I've made it. So now, Y bus here is always going to be the same as Y bus on any other sheet. So if I wanted to add a single net to one of these, I can't do that. I would have to create another definition. So to make it clear, once you've defined Y bus in one schematic sheet, it's going to be exactly the same across all the sheets. If later on you decide that you want to add to it, know that you're going to be modifying it in every single sheet. Okay. But that in general covers everything that can be done with the bus command. So as you can see, its big advantages when you have lots of nets that you can group into logical groupings, such as, you know, an SPI bus, I2C, memory, you know, large 12, 16-bit buses, things like that. That is really where this is designed to shine. And it can make your schematic much easier to read. Because if you have to draw each of these individually, it's gonna become very dense. But by being able to use a bus to kind of consolidate them, it makes your schematic easier to read. So that's what we wanted to cover today on defining schematic connections. These are the main mechanisms. You have net, which you can do point to point, or you can do stubs and give them the same name. Or if your needs are greater than that, then you use the bus command to be able to organize the complexity of your design.
Stay safe. Thank you.
Bye, everyone.